Go on. Still thinking. You all can see my screen. Can someone say yes, please?
Yep.
Yeah, we can see
Yeah,
your
we can.
screen.
Yeah,
Yeah, we
thank you
can
so
see you.
much. I first of all, please accept my most sincere apology for being late. It's so unprofessional. Okay, but I have to go into a meeting regarding people's career, which is tenure and promotion. So that's why I'm late, but there's no excuse for it. Okay. So let's see today's uh today's agenda.
Do you want to get tenure so you can swear in class and not get fired?
Sunshine. I'm been tenured since 2012. Okay. You cheeky sot.
Oh, okay, nice.
Okay. Oh God, my reputation is so bad. Oh, do you want to get tenured so that I can swear in class? Oh God, this is so bad.
I'm joking. Don't worry.
Hey, I believe you had a nightmare Friday lecture, right? Okay. Today we are going to do a topic on combined loading. Okay, and I'd like to apologize. I've not set up a camera so that you can see me. So it's like, am I there or am I not there? Anyway, so tomorrow is March 12th. Okay, so tomorrow from 9:30 a.m. to 10:20 a.m. will be on tutorial. Okay, and the topic I'm going to focus on is on sharing stress, where I finished off the last time to clarify assumption that I've not taught before. Okay, so that is tomorrow. Okay, so for today we are going to analyze. Okay, so for today we are going to analyze. Okay, analyze structures under combined loading. Okay, so this is what we are going to focus on today. So we are going to do combined loading, and before I go into combined loading, okay. Before I go into combined loading, we have more or less studied two different types of loading, okay, and there's one more that you all have been taught in 2P. Okay, there's one you all have been taught in 2P04, and I'll tell you what they are. Okay, so the first one is known as bending moment. Okay, so stresses induced by bending moment. Okay, stresses induced by bending moment. So in bending moment, we already know what formula to use already, right? We are aware what formula that we should be using. So I'm going to write down the most extensive formula used in bending moment. So the formula that we use, the most extensive version, is stress in a certain direction is equal to px over a. Okay, plus by my over iyz plus by mz over izz y. Now, can someone recall, okay, how does the stress distribution look like? Anyone, please? Can someone describe, please? Anyone? How does the stress distribute across the cross section? Anyone, please?
Is it symmetrical?
For this case, it's not symmetrical, okay? But in general, how does the stress distribution look like in general? Give me a very general one. Anyone, please?
The maximum is at the centroid.
No, the maximum is not at the centroid, right?
0 at centroid.
Yes, well done. So that is the most general one, okay? So the most general trend that you see, okay, I finally got my camera on so you can see me. right? So the most general form, okay, in terms of bending stress, right? So this is our stress in the x direction. So let's say we look at y, okay? So we have a trend that looks like this, right? So it will go on one side, right? So at the center, or at the, I'm not going to call this centroid anymore, okay? I'm going to address this as your neutral axis. Okay. Neutral axis. And we know due to bending moment, right? Due to bending moment, at the 0 point, right, will cross at the neutral axis. So we know that. Now let's look at the next. The next one is shear stress or stresses. Okay, so probably I put this normal stress. Then the next one is the shear stress induced by the shearing force, right? By the shearing force. So what we have is we have shear stress, right, is equal to so for this case Vy over Iz, right, Qz multiplied divided by T plus, okay, so we're going to combine two directions because we are dealing with multiple direction now, okay, shear force in the Y and shear force in the Z. So you have Vz over Izz, no, Iyy, okay, Qy, and then we're going to divide by T. Now, can someone remember how the shear stress distribution look like, please? Anyone, please? Can you all
Maximum at
recall?
the neutral axis.
Say it again.
Maximum at the centroid.
Yeah, or neutral axis. Okay, we don't call it central anymore. Okay, we call it our neutral axis. So if we have, okay, so this is our Y again. This is not normal. So this is our shear stress. What we have now, the trend now goes like this. Okay. Okay, so this will be at our tau max. So our tau max is at our neutral axis. Okay. Now there is one more that I've not taught down here, but you knew about this. Okay. So the next one is shear stress induced by torque. Right. So I hope you all know the difference between moment and torque. Okay, if not later on I'll explain. So torque is equal to TR over J. Okay. So can someone tell me how does the distribution look like? Anyone? Anyone?
0 at the center and increases linearly with radius.
Yeah. Okay. So maximum is where? The maximum will be where?
Away from the farthest.
Yeah. And now the graph. Okay, I'm going to use different color now. Okay, now the graph looks like this. Am I right? So I'm going to paste. I'm going to flip this. Okay. So now what we see now, right? This is due to the torque. Okay. So under combined loading, what will you use? right? Is the shear stress to be ignored due to the shear force, or is it just focused on bending moment, right? So, so that is why we have to link this. The only way to link this, okay, the only way to link this is we have to calculate. Okay, the only way to link all these stresses is we have to calculate. Okay, we have to calculate the principal stresses, right? The principal stresses under normal and shearing stresses, or shearing normal or shear stresses. Okay, configuration using Mohs circle. Okay, using Mohs circle. So Mohs circle over here, we are talking about 2D and also 3D. Okay, and then not just constructing 2D or 3D Mohs circle. Okay, then we are going to also apply. Okay, we're also going to apply. Okay, we're also going to apply Tresca vomices or vomices, okay, or Mohs criteria for failure analysis. Okay, so what we are trying to do down here, okay, what we are trying to do down here is we are trying to combine, okay, we're trying to combine both stress strain curve okay, both stress strain curves on, okay, with Mohs circle. Okay, so when we draw Mohs circle, how does the yield strength look like in Mohs circle? Basically, that context. Okay, some of you have taken 3C with me. In fact, most of you have taken 3C with me. I did not teach that yet. Okay, but we're going to combine them. So this combination, again, combining Mohs circle with stress strain curve, you don't get anywhere from textbook. It's when I did consulting, I realized that this is critical. Without understanding Mohs circle and relating to stress strain curve, you cannot decouple them. It has to come together. Okay, so for the next few weeks, what we're going to focus on? Okay, for the next few weeks, we're going to focus on identification of moment, shear force, and torque. Okay, so it's all going to be 3D combined loading. Okay, and you have to ask me how long this will take. This will take about 1 week to finish. Okay, so I'm just giving you the schedule, what we're going to do. Okay, so this will take about 1 week. Then after that, okay, we are going to learn and apply 2D and 3D Mohs circle. So that will take another 1 week. Okay. Then after that, we are going to learn failure criteria. And selection of materials. Okay. So this will take another 1 week. Okay. So if you look at our schedule, this is our week 9,